We are going to study the selection bias as an example of endogeneity problem. As in the lecture, we are going to consider effect of education on wage. Y is wage, X is education. And we are going to assume full rank assumption is satisfied and all the variables are demeaned. Here, the problem is that UI includes all the unobserved characteristics that affect the wage, right? And in class, I usually say intelligence. But X is also chosen by the economic agent, and also there must be unobserved characteristics that affect education choice. And that unobserved characteristics like intelligence would be similar or correlated with the unobserved characteristics for the wage. So two error terms for the wage and for the education are actually similar, right? They must be correlated. So x is determined this way. Epsilon is all the unobserved components that affect education choice, and z is observed uh, variables such as like parents' education level, the family income, or like a fellowship or tuition availability, like things like that. So, and we are going to assume these observed components, observed determinants of education are uncorrelated with epsilon. So it's like linear projection of x into z. But two unobserved variables are correlated, which is pretty natural, right? So the correlation between u and x is the source of this endogeneity. If epsilon was uncorrelated with u, then there would be no problem. I forgot to say that z should be uncorrelated with u. Sorry about that. So show that the regression of y on x does not satisfy the exogeneity assumption. Okay, it's pretty simple. You are estimating this model, and we need to verify this equals to 0. But x follows another structure like this, and we know the main problem is epsilon and u are correlated. So I will assume this is 0. Epsilon, z and u are uncorrelated, but this is not 0. So as a result, this is not 0. That is endogeneity. Okay, that was part A. If you try to identify beta 0 under the standard exogeneity assumption, what would be the misspecification bias? Okay. Here, let me denote like correlation between epsilon and u as raw, and then under your estimating under the standard assumption, you are going to conclude, you are going to assume that basically you will think beta 0 equals this guy. But I will show that the equality does not hold, right? So the true model, include the true model for x implies expectation yi, sorry about that, expectation for beta 0 xi plus ui times xi equals beta 0 exi squared plus expectation xi ui. Now, this guy actually equals raw here, as I assumed above, right? So then pretty simple. The estimate you try to estimate equals beta 0 plus rho divided by x expectation x squared. Okay, so it's bias. This much is bias. Okay, let's think about the then direction of this bias. So denominator is obviously positive, and rho is, so u is, as u increases, your wage will increase. As epsilon increases, your education increases, like intelligence. So obviously, the unobserved characteristics that positively affect the education choice and that positively affect your wage, I believe they are very likely to be positively correlated. So I cannot prove it. It is kind of just assumption from my economic intuition. So I'll assume, I think it's very likely to be positive, right? So intelligence, diligence, right? Your like enthusiasm for academics, like your intellectual ability, all those unobserved things should be positive. So the misspecification bias should be positive. That means the naive estimate will overestimate the true parameter, right? If you do not consider endogeneity, the returns to education will be positively biased. And finally, show that beta can be identified using z as an instrumental variable. So you may just show, like, by the way, I'm sorry, I should have mentioned it in the question. So z should satisfy this, and also z will satisfy this from the linear projection result. And then also, I forgot to say this. Gamma should be non-zero. Under these assumptions, you can show that. So as an answer to this question, you may use like moment condition approach, right? Your moment condition approach is coming from these two. Or you may use fitted value approach that will think about this x fitted value. Or also you may use control function approach, which I do not recommend. It is in the linear model. It's more complicated right now. I'm not going to go into detail. So, but what I suggest here is we know the standard model. So just show that instrumental variables exogeneity assumption. So state that for an IV to identify the model, it should satisfy the instrument exogeneity and instrument relevance assumptions. So under these two assumptions are satisfied, then we identify the model. We know that result from the class, or well known. Exogeneity means Zi, Ui is 0. And IV relevance condition means Z and X are correlated. So this is implied by gamma not equals to 0. Then, and this is also assumed. So the question was not complete. Sorry about